So in this video here, we're going to be talking about coterminal angles. And essentially what coterminal angles mean is that their terminal sides end up being in the same place. And so oftentimes you'll get angles that might be different numbers or different values, but they end up being in the same location or ending up in the same place as even though despite having different numbers. And I'll show you what I mean here in a sec. So to give you an example is, let's say you have an angle like 30 degrees, okay? So if I were to think about 30 degrees, it would sit along here on the initial side, and this is 0 and this would be 90, so 30 degrees somewhere between here. And so this here is 30 degrees. But if I were to really think about it, what if I had another angle? Let's say that it was 390 degrees. If I really think about it, 390 degrees would have went from 0 to 90, then to 180. So 180 would be here, then 270, and then 360. So I'm not at 390 yet, I'm at 360, and then I would have to add another 30 degrees from this initial angle to get to 390. So 390 ends up being the same location as the first angle. So that's what I mean by coterminal angles, is that their terminal angles end up being in the same location after you swing around. So in this case, oftentimes coterminal angles, to find them, you can either add or subtract 2 pi, or in this case, I did it with degrees, so 360. You can either add 2 pi or 360 to land in the same coterminal side or terminal side. So here's what you need to do if you want to find coterminal angles. You'll either add 360 or you'll subtract. It doesn't really matter, but in this case, I want you guys to practice finding coterminal angles, and I want you guys to be able to find a positive one and a negative terminal angle. So to do that, if you're given an angle like this, all you have to do is either add or subtract. And so in this case, let's say I want a positive one. Well, then maybe it's better just to add by 360 degrees, because if I subtract, I'll automatically get a negative. So if I take 115 and I add 360, this should land in the same place. And it should make sense, because if you're going 360, that means you made one full circle. So you should land in the same place if you made one full circle. So if you take these two numbers and you add them, you get 475. I did this with a calculator, so don't be impressed by math skills. I just typed this into my calculator, got 475. For this part, this is only the positive coterminal angle. If I want the negative, maybe I'll take 115 and subtract 360. So if I subtract, that'd be negative 245. Aha, I got a negative coterminal angle now. So these here would be both my coterminal angles. They both land in, actually all three of these land in the same spot. They're just different numbers. They swing around the coordinate system a little bit differently, but they end up all landing in the same spot. And so this one here, I have a negative 35. So this is already a negative number. If I were to add, let's see, if I were to take negative 35 and add 360 to it, I would get 325, which is now a positive coterminal angle. But I need a negative one, so maybe I'll take the 360 and I'll subtract 360. Sorry, I meant I will take the negative 35 and subtract 360 to get negative 395 degrees. And so there is my two angles. So I got one positive, one negative. All right, this one here is now in radians. So when you're dealing with radians, you don't want to add 360 because those are not the same units. So that's when you want to use the 2 pi. So if I have 3 pi over 4, I'm going to add 2 pi to it because I need a positive angle here. So I'm going to add it with 2 pi, but this one's not a fraction, but I can force things to be fractions if I just put it over 1. Right? I can always put something over 1 and make it a fraction. And if I want this 2 pi to have the same denominator, this is a 4, so I can make this guy a 4 if I multiply the top and bottom by 4. Oops. So if I multiply the top and bottom by 4, this fraction ends up being 8 pi over 4. So if I combine, this would be 3 pi plus 8 pi, which is 11 pi. Just add the numerators. Now, both of the denominators should be 4 now, so you'll just carry the 4 over. And I can't reduce this fraction, so 11 pi over 4 is all I can do. And this would be my positive coterminal angle. Now I need a negative one, so I'm going to take my 3 pi. Oops. My 3 pi over 4, and this time I'm going to subtract 2 pi and see if I can turn it into a negative. So again, you're going to have to convert this 2 pi to a fraction that has the same denominator. Now, I've already figured out what 2 pi is. It's just 8 pi over 4. Like, think about it. 8 divided by 4, it's 2 pi. So in this case, I already know that this guy is 8 pi over 4, so I'm just going to subtract 3 pi from 8 pi, which gives me, let's see, 3 minus 8 is 5, and I'll bring the pi over. And then this denominator is a 4, this denominator is a 4, so this is just a 4. So I have 5 pi over 4, and that should be a negative 5 pi since this is a negative sign. So if you didn't quite catch that, let me do it a little bit slower. So this 2 pi can be written as a fraction, but if you think about it, this 2 pi is really 8 pi over 4 if you find a denominator that's the same. When you take 3 and subtract it by 8, you get negative 5, and then I just brought the pi over and the 4 over. And there we go. So we have our answer here. So I have a positive coterminal and I have a negative coterminal. Okay, let's try out D. So for D, we have a negative 9 pi over 4. So again, this one here, I'm going to add the negative 9 pi over 4 with 2 pi. And again, I need a common denominator, so I'm going to make this over 1. The denominator here is 4, so this is going to be multiplying by 4, but I've done this already before. This will end up being 8 pi over 4. And so negative 9 pi minus, or sorry, negative 9 added with positive 8 gives me negative 1 pi. Right? Because negative 9 plus 8 is a negative 1, and then the pi gets carried over. And so then the bottom here are both 4, so I'm just going to carry that denominator over. So this here is technically negative pi over 4. That one there is a little bit redundant, so I'm just going to let go of it. And so this here is not a positive coterminal angle. It's a negative coterminal angle. So even though I added by 2 pi, I still have a negative coterminal angle. So I need another like positive coterminal angle. To do that, perhaps I'll just take this angle here and just keep adding another 2 pi. So this here is still in the same location. So if I add another 2 pi, I can make it positive and it still would be in the same location. So I'm going to take that negative pi over 4, and I'm going to add another 2 pi to get the positive version. So you keep adding 2 pi or you keep subtracting 2 pi until you get a negative or positive number, whichever you need. And so in this case, again, I would put this over 1, but I need a denominator of 4. So if I change this with a denominator of 4, I've done this before, this would end up being 8 pi over 4. So this here is a negative 1 added with a positive 8 makes a 7. Bring over the pi. The denominator is a 4. And carry that over. 7 pi over 4 is a positive number, which is good. So now I have a positive coterminal angle, and I can't reduce that any further. So this is it. So that's how we find coterminal angles, is we either keep adding 2 pi or 360, or you keep subtracting 2 pi or 360 until you have a negative angle and a positive angle. All right, let's take a look at our last concept here, which is special angles, which is talking specifically about supplementary and complementary angles. Now this should seem very familiar because you did, or you should have learned this in geometry. It's a big topic on how to find complementary and supplementary angles. So just as a refresher here, complementary angles are two positive, that's really important, they have to be positive angles. We're not going to deal with negative angles here. Two positive angles that add to give you 90 degrees. Or in this case, what's 90 degrees in radians? Well, that's pi over 2, or half a pi. And then for supplementary angles, that's when you have two angles, two positive angles that add to give 180, or 180 as a radian form is pi. All right. So from here, we're going to take the angle that they gave you. So I'm going to do first in degrees because that's a little bit easier. And we're going to have to find the complementary and the supplementary. So for complementary, essentially, we're going to take the angle that they give us and find the angle that's complementary to it. Or in other words, what's the angle that if I add this, I get 90 degrees. So in this case, the best way to figure that out is just to take 90 degrees and subtract the angle that you have. So if I take 90 degrees, subtract 32, I get 58 degrees. So this here is the angle that is complementary to 32. If I want to figure out the angle that's supplementary, I just take 180 and subtract by the 32. And in this case, that would be 148 degrees. And so this would be the supplementary angle. Okay, now for radians, it's a little bit different because you're going to be working with pi over 2 and pi. So let's start with complementary. So for complementary, I have to take my angle, 2 pi over 5, and subtract it from pi over 2. So instead of 90, you're going to use pi over 2 and subtract it from 2 pi over 5. Now when I look at this here, notice the fractions don't have common denominators, and that's where you need to start. So we need to get common denominators here. So I'm going to take this equation, I have a 2 and a 5, so I need common denominators. 2 and 5 can both be 10 if I multiply this side by a 5 and this side by a 2. So then I would have 5 pi over 10 minus 4 pi over 10. Now I can finally subtract since the denominators are the same. So 5 minus 4 is 1, or 1 pi over 10. Or in other words, this is really just pi over 10. And so this here is my first complementary angle. So if I add this to this angle, they would end up adding to be pi over 2, or in this case, 90 degrees. All right, for supplementary, I'm going to be taking pi and subtracting, or in this case, 180 or pi, and subtracting it from my 2 pi over 5. And again, you want to get common denominators, so you can force this to be over 1. Pi over 1 is still pi. And then to get a common denominator, maybe it'd be easy just to multiply this guy by 5 since the denominator is 1. So that would bring me to 5 pi over 5 minus 2 pi over 5. So 5 minus 2 is 3, or 3 pi, and the denominator here is 5. So 3 pi over 5 is not reducible, so this is my final answer. So this angle, if I were to add it to 2 pi over 5, I should get a pi. In other words, they are supplementary of each other. And that's it for this video. So that is all of the concepts in this journal. Hopefully that helped you walk through some of the skills that we have learned. If you need more practice, try out the practice problems down below. Make sure to show your work if you want those extra credit points.